Okay, so here we're going to evaluate these expressions for certain values of the variable, but before we do it, we want to rewrite these to be in the proper position. We want to jump things over the fraction bar if they have negative exponents, for example. We want to take anything that's to the 0 power, potentially, and um, turn it into 1 and get rid of it. Now, how do we write this first one? Let's see. R to the negative 3 is really saying take r to the third and put it on the bottom. So we have 1 over r to the third. Once we do that, we've kind of gotten it all sorted and simplified. We can now say we're going to replace r with what it's worth. It's worth negative 3. And raise it to the third, because remember, it's now that it jumped to the bottom, it's a positive 3. So what does that mean for us? It means we are going to do 1 over negative 3 times negative 3 times negative 3. That's what it means to cube something, is to multiply it by itself 3 times. So we've got a 1 on the top. What is negative 3 times negative 3? It is positive 9. And what's positive 9 times negative 3? It's negative 27. So we've got negative 27. And if we wanted to, and we do want to do this just so that it makes it easier to see the negative, you can either put the negative on top, negative 1 over 27, or you can put it out front, but we'll put it on top. And let's box the answer for that one. Okay, let's keep going. We've got 4s to the negative 1 for number 40. Actually, let's do 39. Let's do them in order. 39. You see this s to the negative 2 right here? That negative 2 is going to jump that to the numerator. So we're going to have 3r on top, and we're going to jump s now to the positive 2 because we used up that exponent in the jump. And now we have over 1, and we really don't need to write over 1. Okay? So now we have to evaluate it. We say that means 3 times whatever they give us for the value of r times whatever they give us for the value of, what do they give us? They give us, for r, negative 3, and for s, they give us 5. So if we would continue to write that, we would say, okay, then that means 3 times negative 3 times, what is 5 squared? 5 squared is 25. Also known as 3 times negative 3, negative 9 times 25. And if you did that math, you should write it out longhand and calculate it. We would know that, well, negative times a positive is a negative, and 9 times 25 is 225. That's me doing the math in my head because I know it. You should write it out unless you happen to know that with confidence. Okay? Negative 225. Let's continue on. 4s to the negative 1. Well, that's like 4 times s to the negative 1. And what does that mean? Well, s to the negative 1 means you jump that s to the bottom. The 4 does not jump. It's not got that exponent of negative 1 on it. The s jumps to the bottom as s to the first power. And we don't write things, typically we don't write it to the first power, although we know technically that it is to the first power. S to the first power. We consider that to be invisible and we don't need to show it. Okay, so we have 4 over s. Then what does that look like? We've got to say, that means 4 over, what is s? We're going to have to substitute s with its value, and they told us that s is equal to 5 up top. And evaluating that, you get 4/5. And then the last one, we're going to rewrite this as r to the negative 4 times s to the second, just to show that which thing has got a negative exponent on it, just the r. So how do we rewrite that? Well, the s to the second stays on top. The r to the negative 4 is down here as r to the positive 4. And then when we write this, we would say s squared over r to the fourth. And we need to put in what are the values of those numbers. And s is on top, that's equal to 5. R is on the bottom, it's equal to negative 3. 5 squared is 25. Negative 3, I'm going to write this down at the bottom so you can just imagine and see it. That's like, and I'll erase it then. Negative 3 times negative 3 times negative 3 times negative 3. And because we can do these in any order, the multiplication property, the commutative property of multiplication really allows us to say, let's do negative 3 times negative 3, positive 9, and negative 3 times negative 3, positive 9. 9 times 9 is 81. Okay, I'll erase all that. But that equals 81. In fact, as you get more sophisticated about this, you'll learn that anytime you're multiplying an even number of negative numbers, we're multiplying that negative 3 4 times. Each pair of negatives, negative times negative, will cancel out for a positive. So if you have an even number of them, you'll get pairs of negatives, and then you'll end up with a positive number. And what do we get there then? That becomes 81. And it can't be simplified because the 81 on the bottom is just a bunch of 3's multiplied together, and on the top it's 25 is just a bunch of 5's. So there's no common thing to cancel out. So we get, that is our answer.